Hello students, welcome to AIMS India's online classes. Today, from mathematics subject, playing with the numbers topic we are going to continue. In today's video, we are going to solve some previous Olympiad questions which were asked in state level, national level Olympiads in previous years. So let's start with the level 1 practice sheet and first question. Here is the first question. So what are the numbers which have more than 2 factors? Or the numbers which have more than 2 factors are called as what? So the answer is, what is the answer, children? Is it even number? The numbers which are divisible by 2 are called even. So this is wrong. Prime numbers. What are prime numbers? Which have factors 1 and itself. Which have factors 1 and itself. 1 and itself. One minute, children. So which have factors 1 and itself. They are called prime numbers. So but they are asking here which have more than 2 factors. So prime numbers is wrong answer. So the numbers which are not prime means which have more factors other than 1 and itself. Suppose if 8 is there, for 8 factors along with 1 and itself, it is having factors like 2, 4. These kind of numbers will be having more factors, more than 2 factors. So composite numbers is the correct answer. Odd numbers means which are not divisible by 2. Wrong. So according to question, the numbers which have more than 2 factors means the answer is composite numbers. C option is the correct answer. Next. What are the numbers which have only 2 factors? 1 and the number itself. They are called as what? So answer, they are called prime numbers. Means only if 8 is there, sorry, if we have a number like 5, 1 and 5, 1 and itself, these two numbers are the factors. Other numbers, they are not the factors. So prime numbers is the correct answer. Next, third question. Which is the number that is neither prime nor composite? Means we have a number which is not prime, not composite, which does not belongs to prime number set, composite number set. The answer is 1. B option, 1 is neither prime nor composite. Next, fourth one. Which of the following is the LCM of 36 and 72? Which of the following is LCM of 36 and 72? LCM of 36 and 72. So what is their common divisor? What is their common divisor? 2 18 times, 2 36 times. Again with 2 9 times, 2 18 times. Again with 3 3 times, 3 6 times. 3 times, 3 6 times. Can we do by this method? Or what we have, if we write, if we do prime factorization, this is the division method, we can do by this method, or we can do by prime factorization method. So if we continue division method, 3 1 is 3, 3 2 times 6. So 2 2s are 4, 4 3s are 12, 12 3s are 36, 36 2s are 72. 72 is the LCM. 72 is the LCM. Okay, B option is the correct answer according to division method. But we have one more method, prime factorization method, where each number can be written as prime factors, and the factors greatest number of times we have to take and we have to multiply. Like that also you can try, children. Okay, like that you can try and you can find the answer, whether it is equal to 72 or not. B option, 72 is the right answer. So what is the LCM of 17 and 5? What is the LCM of 17 and 5? 17 and 5. So here, what is the nature of 5 and 17? The factors of 5 are 1 and 5 because 5 is a prime number. What are the factors of 17? 17 also a prime number whose factors are 1 and 17. Means if we compare 5 and 17, they have common factor only 1. There is no other common factor between 5 and 17. So they are said to be co-primes. 5 and 7 are said to be co-primes. What is the LCM of co-primes? The LCM of co-primes always equal to their product, 17 into 5. No need to follow division method. No need to follow prime factorization method. Directly we can do the product and we can find the LCM. So why? Because they are co-primes. 17 5 times 85. C option. 85 is the correct answer. So next. What is the HCF of 17 and 5? Just now, in previous question we have seen 5 and 17. What is their nature? Their nature is they are co-prime. Why they are co-prime? They have common factor only 1. That will be the highest common factor. So HCF of co-primes is always 1. HCF of co-primes is always 1. So 1 is the correct answer. A option. So give an example for twin primes. So what are twin primes? The two prime numbers which will differ by a difference of 2, they are said to be twin primes. So here 5, 11 are primes, but their difference is 6. So wrong answer. 3, 5 are prime numbers. Their difference is 2. Correct answer. 11, 17 are prime numbers. Difference 6. Wrong answer. 3, 7 prime numbers. Difference 4. Wrong answer. So only B option is the correct one. After 3, 5, we can observe prime numbers like 5, 7. Their difference is 2. Twin primes. Or 11, 13. Twin primes. Or 17, 19. Twin primes. These are all said to be twin primes. Next. So what is the HCF of two co-prime numbers? Just now we have seen. Repeated question. Answer is 1. For co-primes, always the HCF is 1 and the LCM is equal to their product of co-primes. So option 1 is the correct answer. Next. Which of the following is an example of an even number? How to identify even number? The number which is divisible by 2 is said to be even number. Which numbers are divisible by 2? According to divisibility rules, the numbers having 0, 2, 4, 6, 8 in the units place are divisible by 2. Units place 1, wrong. 7, wrong. 9, wrong. 2, yes. In units place it is having 2. So it is even number divisible by 2. Option D is the correct answer. Next, 10th one. What is the HCF of 120, 144, 216? So 120, 144, 216. What is the HCF? So we have to find the HCF of 3 numbers. 3 numbers. First, we have to check with 2 numbers. We have to find their HCF. With that HCF, with the third number, for the 2 numbers, we have to find again second time HCF. With the first time HCF, with third number, we have to find HCF 2. That will be the HCF of all the 3 numbers. Let's start with these first 2 numbers, 120 and 144. So smallest number will become divisor, largest number will become dividend. 120, 144, 121 times 120, so 24 remaining. So here 120, 120, 124, 5 times 120, 0. Means while dividing with 24, we got 0. So 24 is the HCF of these two numbers is 24. And the third number is 216. With 24, we have to divide 216. With the first HCF, we have to divide the third number. 24 direct 9 times 216, 0. Again, while dividing with 24, we got 0. So 24 is the HCF of first HCF and third number, means HCF of all the three numbers, given three numbers. Okay, 24 is the correct answer. 24 is the correct answer. Next one, 11th one. So, what do you get when you multiply two factors? So, if you multiply, suppose 3 and 6 is there, so we will get 18. What is 18 here? 18 is the product of two factors. 18 is the product of two factors, and these two terms are called factors of this product. 3 is a factor of 18, 6 is a factor of 18. But 18 is product of 3 and 6. Okay, so B option, product is the correct answer. Next. So every number is a dash and dash of itself. Every number is a dash and dash of itself. Because if you take 6, 1 is 6. So the first multiple is first multiple of 6 is 6, and 6 is also divided by 6. So 6 is said to be factor of 6. So for a number 6, 6 acts like multiple, 6 acts like factor. So every number is a factor and multiple of itself. Every number is a factor and multiple of itself. So 12th question, E option is the correct answer. Next. What are the numbers which are multiples of 2 called? Multiples of 2 means all the multiples of 2 are divided by 2. All the multiples of 2 divided by 2 are, if you observe the 2 table, 2 1 is 2, 2 2 times 4, 2 3 times 6, 2 4 times 8, 2 5 times 10. In its unit place, they will be having 2 4 6 8 0. So they are said to be even numbers. All the multiples of 2 are said to be even numbers. Okay. So B option is the correct answer. Next. What is the HCF of the two numbers equal to? The HCF of two numbers. We know the relation L.C.M. into HCF equal to product of two numbers. Product of two numbers. So then what is the value of HCF? Then HCF will be product of two numbers by LCM. Product of two numbers by LCM. According to the relation of HCF and LCM, how to find HCF? Product of two numbers divided by their LCM. So A option is the correct answer. 14th one. Next. So which of these numbers is a factor of every number? Which of these numbers is a factor of every number? Every number. Okay. So which number will be the factor of every number? 1 can be the factor of every number. So B option is the correct answer. Next. How many prime numbers are there between 1 and 50? How many prime numbers are there between 1 and 50? So from sieve of Eratosthenes, in that method we can find how many prime numbers. If you write prime numbers starting from 2, 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a, or let's write with with the help of Eratosthenes, sieve of Eratosthenes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Next 11, 12, 13, 14, 15, 16, 17. Like this, children, up to 50 you have to write. So let's remove this 1, because 1 is neither prime nor composite. Remove this 5, remove this 1. Starting from 2 to keep around, and all the multiples of 2. So 2 2 times 4, strike off. 2 3 times 6, strike off. 2 4 times 8, strike off. 2 5 times 10, strike off. 2 6 times 12, strike off. 2 7 times 14, strike off. Like that, up to 50 numbers, you have to strike all the multiples of 2. Next, round 3, all the multiples of 3. 3, 2 times 6, already it's striked off. 3 times 9, strike off. 3 4 times 12, already it's over. 3 5 times 15, like that, 3 multiples. Next with 5 multiples. Next 7 multiples. Like that, up to 50 you have to do with all possible, and you have to find the number of prime numbers between 1 and 50. Okay, children? So try to find the answer for this question. So it's giving it as a homework, because in the concept already sieve of Eratosthenes we have explained. Use that concept and try to find the answer for 16th question. 16th question. So if you have aimstoday app, then through the app, through chat box, so you can give the answer. You can give the answer. So 6th class, 6th class, 16th question, answer like that, you can post your answer there. Okay. Next. So 17th question. A is the 5th prime number. B is the 7th prime number. So what is B minus A? What is B minus A? So if A is 5th prime number, B is 7th prime number, what is B minus A? What is 5th prime number? 2, 3, 5, 7, 11, 13, 17, these are the prime numbers. What is 5th prime number? 1, 2, 3, 4, 5, 11. So what is 7th prime number? 17. B minus A, 17 minus 11. How much? 16. So A option is the correct answer. A option is the correct answer. Next. 18th question. So what is the number of prime numbers between 50 and 60? What is the number of prime numbers between 50 and 60? This question also, children, you can do with the help of sieve of Eratosthenes or normal method, any method you can apply. Try to find the answer and give the answer through chat box after the completion of video. Not now, children. So after the completion of video, you can give the answers through chat box. So which of the following is the prime factorization of 140? Which of the following is the prime factorization of 140? So 2 into 2, 4 into 7, 28, wrong. Wrong. 2 to the 4, 4 5 times 20, 27 times 140, correct. 2 2 times 4, 4 5 times 20, 140, wrong. So according to option, C option is the correct answer. C option is the correct answer. Next one. So the successor of every even number is. So even number means the general form of even number is 2n. Why means in the place of n, if you keep 1, its value will become 2. If you keep 2, 2 times 4. If you keep 3, 2 3 times 6. If you keep 4, 2 4 times 8. In the place of n, you can keep all the natural numbers and the result will be even number. If for even number form, if you add plus 1, Then what happens? 2 plus 1, 3, odd number. 4 plus 1, odd number. 6 plus 1, odd number. 8 plus 1, odd number. So the successor of even number will be always odd. Not only successor, predecessor, before number, 2n minus 1 also will be odd number. If 2n is even number, successor will be odd number, predecessor will be odd number. So C option is the correct answer. Next challenge. What is the sum of the first 5 multiples of 6? What is the sum of first 5 multiples of 6? What are the first 5 multiples of 6? 6 1 is 6, 6 2 times 12, 6 3 times 18, 6 4 times 24, 6 5 times 30. These are the first 5 multiples of 6. What is their sum? 6 plus 12, 18, 18 plus 8, 36, 36 plus 26, 60, 60 plus 30, 90. The sum is 90. So 21st answer, 90 is the correct answer, children. What is the smallest number which when divided by 20, 25, 35, 40 leaves a remainder of 14, 19, 29, 34 respectively? Means we have to find the smallest number. Let it be x. When divided by these 4 numbers leaves a remainder of this. Because this smallest number is divisible by these 4 numbers, let's find the least common multiple of these 4 numbers, 20, 25, 35, 40. So how to find the LCM? That already you have learned. According to that, try to find the LCM. It will be 1400. After finding the LCM, now if we divide it by these numbers, leaves a remainder of 14, 19, 29, 34 respectively. So 20 minus 14, what is the difference? 6. 25 minus 19, what is the difference? 6. 35 minus 29, what is the difference? 6. 40 minus 34, what is the difference? 6. So this difference we have to subtract from 1400. So it will be 1394. So 1394 is our required number, which when divided by 20 leaves a remainder 14, divided by 25 leaves a remainder 19, divided by 35 leaves a remainder 29, like that. Like that, we will get the answers. So 1394 is the correct answer. Next, 23rd. So what is the least number which when decreased by 7 is exactly divisible by 12, 16, 18, 21, 28? So they have given, they are asking least number. Means indirectly with the help of LCM we have to solve the problem. Least number, let it be x. Exactly divisible by 12, 16, 18, 21, 28. Means we have to find the LCM of these 5 numbers. If you find the LCM of these 5 numbers, it will be 1008. It will be 1008 LCM. LCM of these 5 numbers is 1008. Now the question is least number which when decreased by 7. Which when decreased by 7 exactly divisible by these numbers. So for these numbers LCM is 1008. But our required number decreased by 7. Means for the LCM we have to add 7. We have to add 7. Then 1015 is the required number, from which if we decrease 7, what we will get? 1008 we will get. According to LCM, it is exactly divisible by all these 5 numbers. Okay. First, we have to find the LCM. What is the LCM? 1008. Now, what they are asking? When decreased by 7, exactly divisible by, like that they are telling. What we have to do? We have to add, increase by 7. So 1015 is our required number. So that if we decrease 7, 1008 will come, which is divisible by all. Like that, after finding the LCM, logic you have to apply, whether to add 7 or subtract 7. Regarding that, logic you have to apply. So 1015, C option is the correct answer. Next. So what is the greatest 4-digit number exactly divisible by 12, 15, 20, 35? Exactly divisible by means what we have to do? We have to find the LCM of 12, 15, 20, 35. We have to find the LCM. So what is the LCM? If you try to find the LCM, LCM will be 420. But in the question, what they are asking, what is the greatest 4-digit number? Normally, in math, what is the greatest 4-digit number? We have 9999, 9999. So LCM is 420. This is the greatest 4-digit number. So now we want to find greatest 4-digit number exactly divisible by these numbers. Because 420 is divisible by these 4 numbers, all multiples of 420, 421 time, 422 time, 423 time, 424 time, all multiples of 420 are divisible by these 4 numbers. So let's divide the largest 4-digit number with 420. With 420. 420 2 times 840. So 9, 5, 1, 9. 420 3 times 0, 3 to 3, 4, then 12, 12. So 9, 3, 3. So we are getting 339 remainder. So this 9999 is not exactly divisible by 420, or it's not multiple of 420, because it is we are getting a remainder 339. Suppose from 9999, if you remove 339, so what will be the value? 9660. So this will be divisible by 420 exactly. This will be divisible by 420 exactly, or this is the multiple of 420. So this is the largest 4-digit number which is divisible by these numbers. Okay. So indirectly we have to find the answer. So they are asking to find greatest 4-digit number, but with the exactly divisible by these 4 numbers, we have to find LCM first. LCM will be 420. With that 420, we have to divide the greatest 4-digit number. Then we will get remainder. That remainder we have to remove from that. That will be the answer. B option, 9660. Next. 4 bells ring at intervals 6, 7, 8, 9 seconds respectively. After how many seconds do all the bells ring together? Do all the bells ring together? Means their common multiple we have to find. Least common multiple we have to find. For 6, 7, 8, 9. For 6, 7, 8, 9, least common multiple is 508. 508. 508. So after 508 seconds, they will ring together. After 508, again plus 508. At the time also they will ring together. That's why they are asking first. After how many seconds do they, after this 6, 7, 8, 9 seconds, after how many seconds do they all the bells ring together first? Means we have to find their LCM. We have to find their LCM. Okay, children. That's all for today. So thank you for watching. Remaining problems we can discuss later. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you, children. Have a good day.